A single FA-18 Super Hornet costs $70 million. An aircraft carrier holds 64 of them. That's over $4 billion worth of jets sitting on a floating runway in the middle of the ocean. Now add a Category 5 hurricane with 157 mph winds barreling straight toward it. One wrong move, one loose chain, and a $70 million fighter jet becomes a multi-ton projectile. In July 2022, this nightmare became reality when heavy weather ripped an FA-18 off the USS Harry S. Truman and sent it plunging 9,500 feet into the Mediterranean Sea. The question isn't if storms will hit, it's how the Navy keeps billions of dollars in aircraft from becoming expensive ocean debris. The U.S. Navy operates 11 nuclear-powered supercarriers, each one carrying a small air force worth more than most countries' entire military budgets. These floating air bases face some of the most brutal weather conditions on Earth. Hurricane season runs from June through November, and carriers can't just pull into a garage and wait it out. They operate 24/7, regardless of what Mother Nature throws at them. So how do they do it? How does the most powerful Navy in the world protect its most valuable assets from storms that can flip cars and tear roofs off buildings? Let's start with what we're actually protecting here. A modern Nimitz-class aircraft carrier is a floating city worth $8.5 billion. The newer Gerald R. Ford class, that'll run you $13.3 billion. But the carrier itself is just the beginning. Each one carries between 64 and 80 aircraft, including FA-18 Super Hornets at $70 million each, E-2C Hawkeyes at $80 million, and newer F-35C Lightning IIs that cost a staggering $117 million per aircraft. Do the math. You're looking at over $5 billion in aircraft alone, not counting the carrier itself. These machines aren't parked randomly on deck. Every single aircraft has a specific spot, and there's a reason for that. The hangar bay sits 2 decks below the flight deck, measuring 110 feet wide, 25 feet high, and 685 feet long. That's more than 2/3 the length of the entire ship. This massive garage can hold over 60 aircraft, protected from the elements by thick steel walls and sliding fire doors that divide it into 4 separate zones. But here's the catch. During active operations, most aircraft stay topside on the flight deck, fully exposed to wind, rain, and waves. When storm season hits, the Navy doesn't panic. They prepare, and preparation starts long before the first raindrop falls. Every aircraft on a carrier has multiple tie-down points, reinforced metal rings built into the aircraft structure near the nose wheel and main landing gear. These aren't decorative. They're engineered to handle extreme loads. The tie-down system uses heavy-duty chains, not ropes. Each chain weighs about 15 pounds and stretches roughly 8 feet long. On a normal day, each aircraft gets secured with 4 to 6 chains. But when storm warnings go out, that number doubles or even triples. We're talking 12 to 14 chains per aircraft, sometimes more for heavier planes, like the E-2 Hawkeye or the EA-18G Growler. These chains hook into deck fittings, steel crossbars welded directly into the flight deck at regular intervals. The Navy specs require each tie-down to withstand 16,000 pounds of vertical load. That's not a suggestion. That's a survival requirement. What would you do if you had to secure a $70 million jet in 150 mph winds? Drop a comment below with your thoughts. But chains alone won't cut it. The deck crew, those sailors in color-coded jerseys you see running around, they're the real heroes here. Yellow shirts direct aircraft movement. Blue shirts are the tie-down teams. These sailors train relentlessly on proper securing procedures because one mistake means catastrophe. In April 2025, the USS Harry S. Truman lost an FA-18E when it rolled backwards off the hangar bay during evasive maneuvers. Investigation revealed the aircraft brake failed, but also found insufficient communication between the bridge and hangar control. The plane wasn't properly secured, and gravity did the rest. That aircraft, along with the tow dolly and nearly the crew member operating it, went straight into the ocean. Now let's talk about the hangar bay, the carrier's garage. This is where the magic happens during severe weather. When a storm approaches, the air boss makes the call. Aircraft that can be moved below deck get moved below deck, period. 4 massive hydraulic elevators, each capable of lifting 2 74,000-pound fighter jets simultaneously, work overtime shuttling aircraft down from the flight deck. Inside the hangar bay, it's controlled chaos. The space is protected by an overhead aqueous film-forming foam sprinkler system that uses 94% seawater. Sounds great for fire protection, right? Except seawater in a cockpit causes serious damage. That's why the system is designed not to activate accidentally. During storm prep, every cockpit canopy gets closed and secured. Every panel gets checked. Maintenance crews work double time, ensuring nothing's left open or loose. The hangar bay isn't just safer, it's strategic. Those sliding fire doors that divide it into 4 zones? They're thick steel barriers designed to contain fires, but they also provide structural protection during storms. If one section takes damage, the others remain secure. This compartmentalized design saved countless aircraft during past incidents. But here's the reality. Not every aircraft fits below deck. Space is limited. Priority goes to the most expensive or mission-critical aircraft first. F-35Cs, they're going down. Super Hornets, most of them. But some aircraft, helicopters, and support planes stay topside, and that's where things get intense. Picture the flight deck during storm preparation. Winds are already gusting to 40 mph. Waves crash against the carrier's hull, sending spray 60 feet up onto the deck. The deck crew works in organized teams, moving with practiced precision. Each aircraft gets its wings folded, a design feature specifically engineered for tight deck storage. An FA-18's wingspan goes from 40 feet to just 27 feet when folded. That extra space matters when you're trying to park 20 aircraft on a surface constantly pitching and rolling. The chains come out. Blue shirts attach them to deck fittings in opposite directions, forward and aft, port and starboard. This cross pattern prevents the aircraft from sliding in any direction. Each chain gets pulled taut, tested, then double-checked. No slack allowed. In hurricane conditions, chains get tripled. One sailor described it as chaining down a bucking bull, except the bull weighs 32,000 pounds and costs more than your house. In December 1944, the USS Monterey faced Typhoon Cobra in the Philippine Sea. The storm was so violent it caused fires, washed aircraft overboard, and killed 3 sailors. A young officer named Gerald Ford, yes, the future president, fought those fires personally. The Monterey survived, but the Navy learned brutal lessons that day. Modern procedures come directly from that tragedy, and others like it. Before we continue, quick favor, hit that like button and subscribe if you haven't already. Over 98% of you watch without subscribing, and it costs you nothing but helps us keep bringing you content like this. Now back to the storm. So the aircraft are chained down. What about the carrier itself? These ships don't just sit there and take a beating. They're built to fight back against the storm. Modern supercarriers like the Gerald R. Ford class come equipped with advanced gyroscopic stabilizers, movable blades that compensate for side-to-side rolling. These stabilizers automatically adjust based on wave direction and force, receiving data from gyroscopes throughout the ship. It's like active suspension in a car, except for a 100,000-ton warship. The hull design plays a massive role too. You might think something over 1,000 feet long would be unstable, but carriers are engineered with a critical feature. Their center of buoyancy sits higher than their center of gravity. That means when the ship tilts, physics actually works to right it back up. The farther it tips, the stronger the correcting force. Add to that a wide, flat bottom beneath the waterline, and you've got one of the most stable platforms ever designed. But stability doesn't mean invincibility. During a storm, the carrier will turn into the wind and maintain forward speed. This isn't optional, it's survival protocol. Steaming into the wind reduces the relative wind speed across the deck and keeps the bow pointed at incoming waves. A carrier taking waves broadside? That's a recipe for disaster. The ship uses its twin nuclear reactors and 4 steam turbines to maintain position and heading even in 150 min-ph winds. The bridge becomes the command center during storm operations. The captain, air boss, and senior officers monitor weather data constantly. They're tracking wind speed, wave height, barometric pressure, and storm trajectory. Modern carriers have access to real-time satellite data and reports from Hurricane Hunter aircraft, those crazy Air Force Reserve crews who fly WC-130J Super Hercules directly into hurricanes to gather data. In 2025, Hurricane Hunters flew 927.9 hours through 3 Category 5 storms. Their data keeps carriers informed and safe. Communication is everything. Remember that FA-18 that fell off the Truman? The investigation specifically cited insufficient communication between the bridge, flight deck control, and hangar bay control as a contributing factor. When a carrier makes an evasive turn, say dodging an incoming missile while simultaneously managing storm conditions, every department needs to know immediately. Aircraft need extra securing. Crews need to brace. Equipment needs to be locked down. One breakdown in communication, and million-dollar jets become 1,000-pound projectiles. The watertight integrity protocol kicks in during severe weather. Every hatch, every door, every access point gets sealed. The carrier essentially becomes an airtight steel box. Water that does make it onto the deck needs to drain immediately through scuppers, those drainage holes around the deck edge. If water pools on the hangar deck, you get something called free surface effect, which makes the ship list dangerously to one side. That's how ships capsize, and the Navy takes it seriously. Let's address something important. Storms aren't the only threat these carriers face. In the Red Sea deployment of 2024-2025, the USS Harry S. Truman dealt with storm conditions while simultaneously defending against Houthi-launched anti-ship missiles and attack drones. The crew had to secure aircraft for storm conditions, then make emergency maneuvers to avoid incoming missiles, then resecure everything afterward. It's not just about weather. It's about maintaining combat readiness regardless of conditions. That particular deployment saw 3 FA-18 Super Hornets lost in 6 months. One was shot down in a friendly fire incident. One fell from the hangar bay during evasive maneuvering. One crashed due to arresting gear failure. The Navy's investigation revealed substandard maintenance practices and overall among some personnel. These aren't just mechanical failures, they're training issues, communication issues, and procedural issues. The Navy responded with enhanced training protocols and stricter oversight, because when you're operating billion-dollar assets in combat zones during storm season, there's zero margin for error. The tie-down fittings themselves require constant maintenance. Exposed to salt water, wind, and constant use, these steel crossbars corrode and degrade. The Navy replaces hundreds of tie-down fittings annually across the carrier fleet. Recent SBIR proposals sought more durable materials resistant to both corrosion and abrasion. Every fitting gets load tested regularly. 16,000-pound vertical loads aren't just tested once and forgotten. They're verified constantly because the day you skip that check is the day a fitting fails during a storm and a $70 million jet goes overboard. The crew's role can't be overstated. These sailors, many of them in their early 20s, work in conditions most people can't imagine. Flight deck temperatures in the Persian Gulf exceed 120 degrees. North Atlantic storms bring winds that can literally knock you off your feet. And yet they move aircraft, check chains, perform maintenance, and do it all while the deck pitches and rolls beneath them. The colored jerseys identify their roles. Yellow shirts direct aircraft, blue shirts handle tie-downs, green shirts manage catapults and arresting gear, red shirts handle ordnance and crash rescue, purple shirts fuel aircraft, brown shirts are plane captains, and white shirts are safety observers and quality control. During storm prep, every department coordinates. The air boss in primary flight control oversees everything from his perch above the flight deck. The handler in flight deck control uses scale model aircraft on a representation board to track every plane's location and status. Yellow shirts. guide each aircraft to its designated spot. Blue shirts attach and tension every chain. Final checkers verify everything twice. It's choreographed precision under pressure. Training for this never stops. Carriers drill storm procedures regularly, even in calm weather. New sailors learn from experienced chiefs who've been through actual hurricanes. The institutional knowledge, the hard-earned lessons from Typhoon Cobra in 1944, from every storm since, from every close call and every loss, gets passed down and drilled into every crew member. Because when that real storm hits, there's no time for questions or hesitation. You execute, or you lose aircraft. What happens after the storm passes? The damage assessment begins immediately. Every aircraft gets inspected for corrosion, water intrusion, and structural damage. Salt water is incredibly corrosive to aircraft systems, electronics, hydraulics, engines, all vulnerable. Crews check every panel, every access point, every system. Aircraft that stayed topside during the storm get priority inspection. The flight deck itself needs inspection too. Those tie-down fittings took enormous stress. Deck plates might have shifted. Catapult and arresting gear systems need verification before flight operations resume. The carrier can't just shake it off and launch aircraft. Every system gets checked, verified, and signed off by multiple departments. But here's what makes the U.S. Navy remarkable. They don't just survive storms, they maintain operational readiness through them. During the 2024-2025 Red Sea deployment, despite losing 3 aircraft and facing constant threats, the Truman's Air Wing continued combat operations. They launched strikes against Houthi targets, defended the carrier group, and maintained air superiority throughout the region. That's not luck. That's training, preparation, and the best sailors in the world doing what they do best. The cost of these operations is staggering. A refueling and complex overhaul for a Nimitz-class carrier costs about $2.6 billion and takes 4 years. That includes upgrades to storm protection systems, improved tie-down fittings, enhanced weather monitoring equipment, and countless other improvements learned from decades of experience. The Ford-class carriers incorporated lessons from every previous class: better stability systems, improved hangar bay designs, more efficient aircraft handling systems. Compare this to other nations. China operates 2 aircraft carriers with a 3rd under construction. Russia has 1 aging carrier constantly plagued by mechanical issues. France operates a single nuclear carrier. The United Kingdom has 2 Queen Elizabeth-class carriers. None match the operational tempo, capability, or storm readiness of U.S. carriers. The U.S. Navy's experience is unmatched. They've been operating supercarriers for over 60 years, through every ocean, in every weather condition imaginable. That experience shows in the details. American carriers use catabar, catapult-assisted, takeoff but arrested recovery, allowing them to launch and recover heavier aircraft with full weapons loads. During storms, this system provides more control and safety than ski jump or stow VL configurations used by other nations. The 4-wire arresting system brings aircraft from 150 mph to 0 in 2 seconds, even with deck movement from storm conditions. The hangar bay fire protection system, that AFFF sprinkler setup we mentioned earlier, is sophisticated enough to detect and respond to fires while avoiding accidental activation that would flood the bay with seawater. British carriers in World War II used open-sided hangars that left aircraft exposed to weather. American carriers learned from those designs and built enclosed, protected hangar spaces that could withstand both fire and storms. The nuclear propulsion gives U.S. carriers an edge other nations don't have. Conventional carriers need to refuel, which means they're dependent on supply lines and weather windows. Nuclear carriers can maintain position indefinitely, maneuvering constantly to keep the optimal heading into storms without worrying about fuel consumption. That freedom of movement is critical during extended storm periods. Conclusion. The question wasn't whether U.S. carriers can survive storms. They're engineered to do exactly that. The question is how they protect billions in aircraft while maintaining combat readiness 24/7, anywhere in the world, regardless of what nature throws at them. The answer: engineering, training, procedures learned from decades of experience, and sailors who execute those procedures flawlessly under pressure. From the tie-down chains securing each aircraft, to the hangar bay protecting them below deck, to the carrier's stabilization systems fighting the waves, to the crew making it all work. Every piece matters. Skip one step, ignore one procedure, and you get July 2022's USS Truman incident. Follow the protocol, trust your training, and you get a fleet that's operated through countless hurricanes without losing a single carrier to weather. If this breakdown opened your eyes to what really happens on these floating fortresses during storm season, hit that like button and subscribe for more in-depth military content. The U.S. Navy's storm procedures represent just one aspect of carrier operations. There's an entire world of tactics, technology, and training keeping these ships operational.